Imagine a sunny day. How does the heat from the sun get to you? As you should recall, heat is transferred in three ways: conduction, convection, and radiation. Now, the sun is 93 million miles away, and there's not much between you and the sun. It's practically a vacuum. You can't touch the sun, so the heat certainly can't get to you through conduction. And there's no liquid or gas between the Earth and the sun, so convection is not the way you get the heat. Well, the answer to how do we get the heat from the sun is thermal radiation. In order to understand thermal radiation, we've got to know a little bit about the electromagnetic spectrum. If you're like most people, when you hear the word light, the first thing that comes to your mind is the type of light that we can see. This kind of light, or this kind of light, or this kind of light, or maybe even this kind of light. But there are many other types of light that we can't see, but we can detect in other ways. The electromagnetic spectrum is the complete spectrum of all the different forms of light. It consists of electromagnetic waves, which are electric and magnetic fields that vibrate perpendicular to each other. Now, we can't see these waves with our eyes, but this model kind of shows how these waves travel. Electricity and magnetism are very closely related, and they travel together. Radio waves, microwaves, infrared radiation, visible light, ultraviolet light, X-rays, and gamma rays are all forms of electromagnetic radiation, and these are probably familiar to you. If you listen to the radio, well, it's radio waves that bring those signals to your radio. Most of us use microwaves to make our food or our coffee hot, and this is a kind of electromagnetic radiation. Infrared radiation is heat radiation, and everything in the world that's above absolute zero actually gives off heat radiation. We all know visible light. That's what allows us to see things. Ultraviolet light is that light that comes from the sun that we can't see, but if we get too much of it, we can get a sunburn. X-rays are used in medicine to see bones and other stuff, and gamma rays are produced by the stars. They're pretty dangerous waves, pretty high energy waves. But all of these waves are forms of electromagnetic radiation. This diagram shows these different types of waves. And it also shows the energies that are associated with these waves. Some types of light, like radio waves, have very low energies and they have very long wavelengths. But other types, like X-rays and gamma rays, have very high energies and very short wavelengths. So one of the trends we see is that the shorter the waves, the higher the energy of light. Now, thermal radiation means the transfer of thermal energy by electromagnetic waves. Now, remember that these waves are not matter. They involve pure energy. All matter with a temperature above absolute zero radiates these, even you. And it's possible to see thermal energy using special cameras. And this can be pretty cool. Thermal radiation can happen through solids and liquids and gases, but it can also happen through a vacuum, and a vacuum is not a vacuum cleaner. It's basically empty space with no particles in it. When thermal radiation strikes particles of matter, it gives them energy and it makes the particles vibrate, and this causes the object to warm up. And as you should know by now, the faster these particles vibrate, the higher the average kinetic energy the particles have, and the higher the temperature is. And this is how the sun warms us on a sunny day. And without the energy that's radiated from the sun, Earth would be too cold to support life as we know it. So, in summary, radiation is one of the ways that heat can be transferred. It involves electromagnetic waves, and these waves can travel through solids, liquids, gases, and even through a vacuum. When these electromagnetic waves hit matter, they give the particles energy, and that makes them vibrate. And that increases the temperature.